Our next class of organic compounds that we're going to talk about are lipids. Lipids, our subunit, are going to be glycerol and fatty acids. These are composed of carbon, hydrogen, oxygen, and often there's phosphorus contained in lipids as well. So you notice that we've got a trend starting here: carbon, hydrogen, oxygen. We know that lipids are insoluble in water, oil and water. They don't mix, they separate, right? But they are going to be soluble in organic solvents, ether, chloroform, stuff like that. Just like carbohydrates, or complex carbohydrates are formed, lipids are going to be formed by dehydration synthesis as well. So what we have here is an example of our fatty acids, right? So we've got 3 fatty acids here, and we have our glycerol molecule. And what's actually going to happen is that our glycerol molecule is going to bond numerous times. It's going to bond here, there, and there. And what you'll find is that we actually end up getting 3 water molecules in order to get this lipid. We have 3 main subgroups of lipids. Those are fats, phospholipids, and steroids. Phospholipids and fats are ones that we typically tend to focus on. Steroids is a very wide category that we don't focus quite as heavily on. But we have some examples here of our fats in this picture right here, our phospholipids in this particular picture here, and then our steroids. So fats, all right? We should know that they're going to give more energy than carbs. But they're stored more as well. All right? So although they're going to supply more energy than a carbohydrate is going to, any excess is obviously going to get stored, so that's a negative side. Again, composition, carbon, hydrogen, oxygen, but they have a lot less oxygen, substantially less oxygen. Those fats, again, are composed of glycerol, and in this case, it's 3 fatty acids that are going to end up being combined. So we call it a triglyceride. So you end up having that glycerol and 3 fatty acids that come off of it. And fats can be saturated or unsaturated. So here's our picture of that lipid, and like I talked about, that glycerol molecule, and 1, 2, 3 fatty acids. So saturated. Easiest way to think about this is that, like, if you're saturated with sweat or saturated with water, totally full, soaked, however you want to think of it, this is when fatty acids are linked by single bonds. They're full. In this case, they contain as many bonds as they possibly can. They're full of as many hydrogens as possible. So our fatty acids are depicted in red here, and you can see that every single one of these carbons is bonded 4 times. 4 times to 4 separate atoms. All right, there's no doubling up, tripling up, or anything like that. So in this case, this fatty acid is completely full or completely saturated. It has as many bonds as possible. Versus unsaturated, which obviously means it's not full, is going to be when you have double bonds forming. So you can have mono unsaturated if there's 1 double bond, or polyunsaturated if there's 2 or more. Our picture here shows that we have a mono unsaturated fat, and that's because there's 1 double bond. You'll see that where we would typically think 1 more bond would be on each carbon, instead they double up the bond between one another. So it makes it unsaturated. It's not completely full. It's not holding as many atoms as it possibly could. So that saturated versus unsaturated fats, saturated fats are going to be the solids at room temperature, and unsaturated are going to be liquid at room temperature. Those solids, if you eat a lot of them, those saturated fats, they're going to increase your risk for heart disease, while unsaturated fats tend to be the healthier substitute. So I guess you could kind of think of them as being healthy. Oops. versus unhealthy fats, we're talking butter, lard, bacon grease, because as bacon grease cools, it does solidify, and things like that, versus here, we're talking about olive oil, right? We're talking about vegetable oil, liquids at room temperature, guys. Then our phospholipids, which should be very familiar to us because we talked a lot about these last year when we specifically addressed the cell membrane, right? Huge structural component of the cell membrane. In this case, it contains a glycerol, but only 2 fatty acids. So you're going to have that glycerol molecule, but only 2 fatty acids coming off of the glycerol. The third bonding site where you typically would have a extra fatty acid instead is actually going to have a phosphate group that comes off of it, right? Which has more than just the phosphorus. That phosphate head is what we refer to as hydrophilic. We should know that hydrophilic is referring to water-loving versus hydrophobic being water-fearing. And those hydrophobic are the fatty acid tails. And that kind of creates that phospholipid bilayer that we talked about last year in biology class, and addressing the fact that the heads were always in contact with the outside or inside liquid component, while the tails, which were hydrophobic, were in that middle space between the 2 layers where typically water was not being held. So our example here being that we have one of our fatty acids, a second fatty acid, our glycerol molecule, and we've got our phosphate group. Our steroids are going to be, like I said, the most complex out of the lipids. Typically, they're not in chains. They're instead going to be in rings. You may have noticed that on our first slide when we were talking about lipids, that everything looked like chains, and then we had the steroids that were rings. Examples would be cholesterol, right? And many of our hormones as well, sex hormones specifically, like testosterone, are going to be steroids. So just a quick little table that wraps up our lipids and kind of gives them a quick little overview.